summary for San Francisco, we ended up with 51, 54.5, 58, 60.5, and 63. And the point of the 5-number summary is to break it out into quarters, which is why we needed quartiles. So even though we have 5 numbers, we can look at this as kind of breaking the total range of data into these 25% chunks. So the first chunk is going to be between 51 and 54.5. So you can see that takes us from our min to our Q1. Then the second quarter chunk is going to be 54.5 to 58. So this takes us from Q1 to the median. Then we'll see another quarter going from the median to Q3. And then lastly, we have from Q3 to the max. And so if you actually look at this visually and spatially, you can see that each green bracket contains 25% of the data that's listed. So that is to say 25% of the data is at or below 54.5. So you want to think about cumulative data. So everything up to that point. So if we started at the beginning and we went to 54.5, we would have covered 25% of the data. And we can keep moving right. So if we go further to the right, we end up in the median, we would have covered already then 50% of the data. So we could say 50% of the data is at or below 58. And if you notice the bottom of the screen, you're seeing this pop up. We just said the 25th percentile is 54.5. The 50th percentile is 58. So all we're doing with percentiles is we're just saying how much data have we covered up to this point. And so our 75th percentile is going to be at 60.5. That means 75% of the data we've covered up to the time we get to 60.5. And you could say the 100th percentile is at 63, but no one talks about that. So, all right. As far as notation is concerned, we're going to use capital P, and then we're going to have a subscript. And the number in the subscript is going to tell us what percentage we've covered so far. So in this example, we took the 5-number summary. The 5-number summary gives us the 25th percentile, which is P25, the 50th percentile, which is P50, and the 75th percentile, which is P75. Again, I could write P100, but no one really talks about the 100th percentile. And notice that 54.5, 58, and 60.5, those are our Q1, our median, and our Q2. And our Q3, sorry. So the definition, you don't have to restrict yourself just to 25, 50, and 75. You could have any value between 0 and 100 for your percentile. So the kth percentile is a value that separates the bottom k% from the rest of the data. And as I said, we're going to write it with a capital P, and whatever percent you've covered up to that point, that's going to be a subscript or a small number. In general, we could write PK, but we could have P sub 10 or P sub 85 or whatever percentile we wanted to denote. So here's an example, and please pause it to give yourself a moment to answer in earnest. We've got 2 students, Z and Beta. Z was in the 90th percentile and Beta was in the 10th percentile for their final exam scores. And I'm asking who had the higher score. So take a second, think about that, and I'll answer it when you come back. All right, so kudos to those who actually paused it. And I hope you enjoyed the short break for those of you who didn't pause it. So who had the higher score? Well, it's gonna be Z, because Z, it was in the 90th percentile of their final exam, meaning that Z beat 90% of the class. By the time you get to, if you listed low to high, all the scores in the class, you would have to go through 90% of all the scores until you got to Z. So that means that Z is at the near top of their class. Conversely, you would only have to go through 10% of the first bottom scores to get to Beta. So beta didn't score very well relative to their classmates. All right, there's another way to look at percentiles, and this kind of draws upon our understanding of cumulative frequency and relative cumulative frequency. And we also need to know how to convert decimals to percentages here. So if we have a cumulative frequency and relative cumulative frequency for group data or a general frequency distribution table, we can actually just read off percentiles from the chart itself. So remember that cumulative frequency and relative cumulative frequency measure the up to this point value. So if I were to look at the cumulative frequency for 2, for example, going over to the 4th column under cumulative frequency, it would say the number 51. And that means that by the time I get through 0, 1, and 2, I've already covered 51 data points. So that would be the 10 zeros, the 25 ones, and the 16 twos. That gives me 15. I have 91 total data points. My sample size, little n, 91. So I could convert this 51 from cumulative frequency into a relative frequency. And we've done this many times. By doing 51 divided by 91, that's going to give me a percentage. So instead of saying, oh, I've covered 51 data values, I can say, oh, I've covered 56% of the data values. And where I'm getting that 56% from is in the last column for relative cumulative frequency. I'm looking at 0.56. I'm converting it to a decimal. I'm converting it to a percentage, and then I'm claiming that as my percentile. So I'm saying 56% of the data has been covered by the time I get to 2 or through 2. Hence, the 56th percentile is 2. All right, so let's try one more time. What is the percentile for 4? So the action is look at your row for 4. You want to follow it over to your relative cumulative frequency. And what this is saying is that up to this point, I've covered 74.725 blah, blah, blah % of my data. That is a different wording for describing a percentile. So I'm converting it to a percent. 74.7% of data is at or below 4. Again, that is just a different way of saying 4 is the 75th percentile, or I could write P subscript 75.